In section 4.6, we start to talk about the different types of reactions. And the first one we're going to talk about builds off of this last section where we talked about the solubility rules to talk about precipitation reactions. Now, precipitation just means to form a solid in terms of aqueous solution chemistry. And a precipitate, usually abbreviated PPT, is just the solid itself that formed during a reaction. So what does it mean to be soluble? First, we have to kind of understand that to kind of get this idea of what insoluble means as the end of a reaction. Well, if I have potassium iodide as an aqueous solution and lead nitrate as its own aqueous solution, what soluble means that all of the ionic bonds are broken and the individual ions are dissolved and surrounded by water molecules. So potassium iodide will actually exist as a sequence of potassium cations and iodine anions. Now potassium lead nitrate will exist in the same way because it is aqueous, because all nitrates are aqueous, right? As a series of lead ions and twice as many nitrate ions. Now the nitrogen and the oxygen don't come apart because in this polyatomic anion, the nitrogen-oxygen bonds are covalent. So if I mix the two together, right at the moment that the two are mixed, they exist as this whole bunch of ions, lead and potassium and nitrate and iodine ions. But then immediately, very quickly as a matter of fact, in fact so fast that when you pour these two together, as we do in our laboratory that's associated with this, you don't even really see a lag between the two. You just immediately see a solid form, which is kind of a bright yellow solid, and the potassium and nitrate ions will stay in solution. So this lead iodide solid compound is the precipitate for this reaction. And something I'll point out now that we'll talk about more later are the potassium nitrate ions. If you think about it, they were nitrate to begin with and potassium to begin with. And when we mixed them, they were still potassium and nitrate. And now they're just potassium and nitrate as well. So in a way, the potassium and the nitrate really didn't do anything at all. So we refer to those as spectator ions. Spectator, or whatever. Ions, potassium and nitrate. So we're just naming them as species. And the real reaction here was only between lead and a couple of chloride ions forming lead chloride solid. In fact, any source of lead that's soluble combined with any source of chloride that's soluble will give you this exact same exact same set of observations. You mix the two together, you get a precipitate formation. So the way you can kind of predict this when you just see the reaction written as a reaction and you're not actually in the lab and experimenting is by seeing this as a double exchange or double replacement reaction. Now you might have heard of this before as a metathesis reaction. And all we do here is exchange partners. So if I have some two ions attached together and two ions attached together, the cation of the first and the anion of the second will combine to form a new compound, and the cation of the second will combine with the anion of the first and form this new species on the product side as well. Now keep in mind when we rewrite these, we're actually going to write this in reverse. We'd put C first, wouldn't we? CB, because C is the cation here. But otherwise, all we do is just switch partners and rearrange. Now, to do this with actual ions, let's take a look. Potassium ions are going to mix with nitrate ions. and we'll get potassium nitrate, and then we'll have to balance this. Potassium is +1, nitrate is -1, so a 1-to-1 ratio works just fine. Don't assume the ratios transfer, they don't. Now lead will mix with iodine to give us lead iodide, and this is lead 2 ion because there's 2 -1 nitrates attached to it. So that means +2 -1, and we'll need 2 iodine atoms for lead 2 iodide. Excellent. So now that you've completed the reaction just by switching partners, you've balanced the individual molecules by their charges. Now we have to balance the overall reaction. Okay, so potassium, potassium, 1 on each side. We have 1 iodine, 2 iodide ions, 1 lead, and 2 nitrates, and 1 nitrate. Okay, so first thing we have to do is get more iodine. So now we have 2 of those, but we also have 2 of the potassiums. That means we're going to need 2 of these, so 2 potassiums and 2 nitrates. Now we have 2 and 2, 2 and 2, 1 and 1, 2 and 2, balanced. Good. Check. Then we have to see what is soluble and what's not, so we can put states of matter in. Okay, well, potassium iodide is aqueous from 2 different directions, right? Potassium salts and iodine salts. Lead nitrate is soluble because all nitrates are soluble. Potassium nitrate, all nitrates are soluble and all potassium salts are soluble. And lead iodide, all halogen or halide salts are soluble except mercury, lead, and silver. So this is one of the exceptions to iodide ions making a soluble compound, so this is solid. So this is the full, complete, and balanced precipitation reaction. Alright, so you give these a try. Pause it, do the same thing I just did, unpause it, see how you did. Alright, so we're back. AgCl, the Cl and the Ag, we're switching partners. +1 and -1, check. Ca, cations first, nitrate, +2, -1. I'm going to need 2 of these. Good. All nitrates are soluble. All chlorides except silver, lead, and mercury. So soluble, silver, lead, and mercury. So that's a solid because of the silver. All nitrates are soluble, no exceptions. Aqueous. Alright, so 1 silver and 1 silver, 2 nitrates. I'll put 2 there. 2 silvers and 1 silver. You have 2 here. 2 silvers, 2 silvers, 2 nitrates, 2 nitrates, 1 calcium, 1 calcium, and 2 chlorides, 2 chlorides. We are done with this one. If you haven't tried the other one yet, make sure you do. And we're back. Okay, so this is mercury 2 nitrate. So mercury and chloride ion. And sodium and nitrate. So mercury 2 chloride means that we'll need 2 chlorides, and sodium and nitrate plus and minus. That gives us 1-to-1. Good. So now we balance it. Sodium and sodium, mercury, mercury, 2 chlorides. So 2 chlorides. That gives us 2 sodiums, 2 nitrates. Done. Nitrates are soluble. Group 1 metal salts are soluble. Mercury is an exception to the chloride rule, and all nitrates are soluble. And that's it.